At the beginning of every day, I list the names of people I'm going to be talking about, the main concepts I'm going to be talking about, and so on. And that all of the slides for this class can be reviewed in the class is being podcasted, so all of the slides and my comments can be reviewed in podcast.ucsd.edu. When the last class ended, we were asking the question, were Australopithecines human, or simply were they bipedal apes? And by human in this case, I mean human ancestor. Before we can answer that question for the Australopithecines or for any of the other fossil remains that we're going to be discussing in the next couple of classes, I think we need to take a little break and talk about what exactly is how can we define what do we mean when we say that some fossil is a human ancestor? What exactly, how exactly do we differentiate what is to be human? That is a very deep philosophical question that could have an infinite number of answers, and I'm going to provide a very narrow anthropological one in this class. But I am quite aware of the complexity of the question and of the inadequacy of my answer. Ask the question of what it is to be human. Most people would probably respond, would try to abstract and try to find the things that truly humans, that are uniquely human and no other animal possesses. And most people would probably answer something in the order of ethics, morality, issues of ethics, issues of morality. And I would say you're probably quite correct. However, as an archaeologist who deals with the archaeological record, I'm not entirely sure how I'm going to go about determining issues of ethics and or morality in the archaeological record. In other words, whether or not it is correct that the irreducible thing of being human is a consciousness, a certain degree of consciousness, and a certain understanding of what constitutes a moral universe. If that is what really being human boils down to, I'll never get at it with the archaeological record is my problem. The question is, are there other things out there that could be used as proxies that can indeed be gotten at through the archaeological record? Many other people, when asked what it is to be human, would probably point to achievements in literature, in art, in science, and math. And what is common to all of these areas of endeavor is abstract reasoning. The idea being that while animals reason, abstract reasoning would be a characteristic of humans and not of animals. Again, this is notoriously difficult to, reasoning is notoriously difficult to determine in the archaeological record because, of course, mental processes are not preserved per se. Only artifacts created by mental processes are preserved when, of course, inorganic. Again, you may be quite correct that abstract reasoning is a characteristic of humans and not of animals, although, of course, it would depend. I suspect that it's not black and white, and that some animals may have some of it, and it's an issue of not presence-absence, but relative amounts, as we learn more and more about the mental processes of animals. So while it is very clear that abstract reasoning is indeed, is without certainty a characteristic of humans, it is very possible that some degree of abstract thought may also be found in animals, and we'll talk about a little bit more about that when we look at the case study of Coco, the so-called talking gorilla, which we will do today. So abstract reasoning is, number one, it doesn't help us much because it's not easily found in the archaeological record and because it may not be a really clear line in the sand either. Typically human, of course, is symbolic, a symbolic language-driven culture that can be shared with peers and then can be passed on to descendants. Essentially, a culture, a way of understanding the world that you share with the people in your own society and that you pass on to your offspring. A culture that is reproducible, that can be taught, which is presumably part of what we're doing here today. And I think that that is very clearly, having a culture that is reproducible is very clearly human. The question, of course, is the degree to which animals have cultures too. And that too is, and again, the point I'm going to try to make later on is that this is not a presence-absence issue. It used to be believed until not that long ago that if you ask somebody what's the difference between humans and animals, the knee-jerk reaction would have been, we have a culture and they don't. But that too is no longer particularly clear these days. So it may be an issue of how complex is our culture as opposed to theirs. Levels of complexity, blurry lines in the sand rather than lines in the sand. On the issue of cultures, it used to be believed that, of course, the tool use, which tool use is a technology and by definition is part of a culture. To give you an example of the blurriness of the lines, it used to be believed that tool use was a very typical human characteristic, not shared with animals. And that line in the sand has certainly been obliterated by observations such as these. Higher primates are regularly observed using tools, unmodified tools, as I briefly described, and other animals, such as birds, have also been observed using tools. Again, time and again, everything that we thought makes us characteristically and uniquely human is not so clear at all. The point I'm trying to make is that culture is a continuum, and drawing a line in the sand of something that makes us uniquely human and something that animals do not have is not at all clear. There is, in fact, a new synthesis on the question of animal culture, published maybe 10 years ago or so, which explores the debate looking at great apes, looking at marine mammals, and a variety of other species. And oversimplifying the conclusions of this compendia, over the last 3 decades, the debate has gone from a clear separation between animals that, quote unquote, were presumed not to have culture, and humans that are known to have culture. That line, certainly, as I said, is no longer at all clear. What is clear is that the question comes down to the complexity of cultures. A number of different species are able to use the one thing, a symbolic, language-driven culture. Our ability to speak aloud and create worlds that can be understood by others, even though those worlds may not be immediately visible in front of them, and so on. So the ability to convey symbols by using sound, which is another one of those things that used to be believed that only humans would have, that too is not at all clear anymore. Recent observations, repeated recent observations of vervet monkeys have been made in which they warn each other with uniform calls that are identical in each case and that are widely and immediately understood by the troop of monkeys to mean there is a snake. If you are a vervet monkey, your worst predator is indeed snakes. So every time this particular call is made, that call is immediately understood. That call is functionally identical to what we would call a word. There is simply no difference between that call and the word snake. The reaction is is exactly the same. So you could argue that some primates, like vertebrate monkeys, capuchin monkeys, vertebrate monkeys have calls for snakes, capuchin monkeys have calls for eagles, both very effective in warning their peers as to the danger, the immediate danger. You could argue that, in a sense, this is a simple, primitive, but effective language. So language, too, is not a clear line in the sand. So these we walked into this room, to give you an instance, through an opening that can be barred by a piece of wood that stands vertically. We, in the culture-bound world of those that share the English language, call that piece of vertical wood a door. There's nothing about it that requires it to be a door, and in fact, other culture-bound individuals, human individuals, call it other things. So in a sense, the ability of vertebrate monkeys to have that particular call and have that call be immediately identified with a warning call for the presence of a snake is equivalent to our ability to name things. So they have the ability to use symbols, sonic symbols in this case, that particular call, or our use of the word door to signify not any piece of wood, but one that stands at the threshold between one space to the other. Because that same piece of wood, or any other piece of wood, in a different context would have been called differently. So in a sense, we have the ability to use sonic symbols to convey meaning, but so do vertebrate and capuchin monkeys. I have mentioned that one of the characteristics of culture is that it is shared within a group, and it tends to be transmitted both vertically across generations within a group and horizontally between the members of a group. There's a very interesting study by the biological anthropologist Andrew Whitten, which was published in the journal Nature about 20 years ago, in which he actually observes chimps in the wild that use stones as tools. And what he has observed is rather interesting. Troops of chimps that tend to use stones, when a troop of chimps will use stones, all of the members of that troop will know the use of stones in a particular way, to be, for example, to use stones to crack nuts. Some other troops of chimps do not have that particular ability. In other words, the knowledge, the understanding of how to use tools has been transmitted to the peers of a culture-bounded group, but not necessarily to the other. So this is it is very clear that the use of tools is taking place within the context of a culture that can be transmitted. A culture that can be transmitted, yeah, that's what we do. Well, it so seems that that's what they do too. And some groups have it, and some groups do not. Again, every time I try to put a line in the sand is really, really difficult. So having a culture that can be transmitted, being able to use tools in and of itself is nothing that makes us humans. And more likely than not, we need to think in terms of the level of complexity of that culture and the level of complexity of the technology. So having technology, having culture are not things in and of themselves that are determinative. What is determinative is the level of complexity. As I mentioned before, when you actually see animals using tools, having technology, it's always a technology that uses ecofacts, things that exist in nature, and converts them and uses them, in so doing converting them into artifacts for a particular purpose, but they are essentially unmodified. Whereas the sorts of tools that we use can very much be unmodified. Who among us has not taken a stone and used it as a hammer? And that is an unmodified tool, but most of our tools are thoroughly modified, like the computer sitting in your hand, for instance, and so on, made from many different parts put together to create a whole that is much more than any single part. That is very different from, so tool use doesn't work, but the use of modified versus unmodified tools does work, or at least thus far. I would not be surprised if somebody ever found a chimp that can actually, that has some ability to very simply modify a tool. That remains to be determined. So I do not claim to answer, that I know the answer. So what I'm really saying is that it's a gray issue. That is an issue of not of presence-absence, but it's an issue of a certain level, threshold of complexity. And I do not know, nor do I think anybody knows, where exactly the line is. There's a very fuzzy line. Where exactly that line is not at all clear. So the question really comes down to what is the level of culture that a group must have in order to behave in a human fashion. We will come back to that question when we talk about Coco. So since it is not simple to define what is human, and more difficult still to define at what point can we call a certain set of behaviors human, let's look at some of the principal behavioral differences between most great ape societies and human societies. The famous paleoanthropologist Glenn Isaac from Harvard University, a thoroughly brilliant man who died in his early 40s, regrettably, lists 6 essential differences between ape and human societies. He is confronted. Essentially, he's trying to do exactly what I'm trying to do. Look at the early fossils and say, which ones of these are going to be human ancestors? Which ones of these are not? The only reason, there's Australopithecines, there's Homo habilis, I'll talk a little bit more about Homo habilis later on. The only reason Homo habilis is called Homo habilis is because we are certain that they used tools. And in the 1940s, as I said before, as a result of the work of Kenneth Oakley, the book Man the Toolmaker, 100 years ago it was thought that the use of tools was one of those very clear red lines on the sand. We no longer think that. Had that theoretical construct not existed, I am not at all certain that Homo habilis would have been characterized as Homo as opposed to a different genus. The question is, how did they behave in groups? And that's what I'm going to try to get at by looking at the work of the parameters that Mr. Isaac discusses. So he talks about the differences between human societies as a group and ape societies as a group. He says humans are bipedal and habitually use their arms to carry around tools, food, and many other things. We all understand that quite clearly. As to the issue of communication, he says, while apes communicate with each other, none does so with a spoken language. I'm not entirely sure I would agree with that. Those vervet calls are an exceedingly simple form of symbolic spoken language. But we could argue on that one backwards and forwards. What he really means is a language that has formal characteristics, that has a grammar, that has an object, a subject, a verb, and so on. That's what he really means, as opposed to a single utterance that has a symbolic meaning. The question really boils to is this a complex grammatical language? Is a complex grammatical language something that characterizes only Homo sapiens sapiens? It's very clear we all have it. How far back into prehistory can we trace the ability to communicate in complete sentences that have an object, a subject, and a verb, that have a sense of nuance, that have a sense of time? How far back can you trace that? Certainly to Homo sapiens sapiens. Can we trace it all the way back to biologically, the biological origins of Homo sapiens sapiens? Or is it a later development of Homo sapiens sapiens? And did earlier hominids have it? Did Erectus have it? Did Homo habilis have it? All of these are questions that are not answerable at this time. Answering the question of language is, of course, not clear, because language does not fossilize, and neither do brains. Not all language is necessarily verbal. A lot of language is gestural, of course. Anybody that understands American Sign Language understands that you can perfectly communicate, you can communicate perfectly in complete sentences that are perfectly grammatical using nothing but gestures. So, and gestures too would not fossilize. And in fact, many linguists that have hypothesized, and I use the word hypothesize, about the origins of language, and they hypothesize because there's very little actual physical evidence for it, are quite suspect that the earliest languages were entirely gestural, and it is only later that they started to become combinations of gestures and utterances, and eventually became largely composed of words. The anthropologist Richard Klein from Stanford tries to, in his work, which we will look at a little bit later on in this class, tries to understand the origins of modern languages and suggests that modern languages are a very recent phenomenon. By modern languages, I don't mean any particular modern language, but complex language, complex grammatical, syntactical languages. And he suggests that these are only a very recent addition to the human repertoire, dating perhaps only 50,000 years ago. That is hotly debated. We'll come back to it. The point being, of course, that if we could figure out, if we could put our finger in when is the origins of complex grammatical, syntactical languages, whether it be gestural or sonic, we could most assuredly address the question of what is human. But we certainly do not have that ability to find this easily at this point. You both have heard, of course, of the so-called talking gorilla Coco, who died recently. She was taught by her trainer, Penny Patterson, at Stanford University, to use sign languages, and eventually a lot of the interactions were recorded. It was said that her language vocabulary consisted of up to 1,000 words, which she and her trainers say that she was able to use in complex grammatical statements and questions. So essentially, she had a gestural language that would be considered modern, typical for a human. And yet, and I don't think anybody would really disagree that this is documented. The complexity of the interactions between the trainers and Coco have been documented extensively. I don't think anybody would disagree that Coco could express herself in complex grammatical statements. But Coco, of course, is unique. She was trained by humans. Gorillas in the wild have never been observed to use a gestural language. So clearly they have the potential, but absent human intervention, was that potential ever realized? That is indeed a very good question. If gorillas today have the potential for complex grammatical syntactic language, would it not stand to reason that some of our much earlier human ancestors may also have had the same potential? But having a potential and expressing it are two things, two entirely different things. In any event, the whole question of potential makes it clear that the difference between humans and non-humans is not one of essence, but is one of degree. And it may very well be that the difference between Homo sapiens sapiens and the earlier hominids, again, is not one of essence, but one of degree. That in a sense, we are simply much more complex versions of beings that had potentials that we would consider to be human, but may not have been, may have been only partially or fully expressed. So the whole issue of language is open. It is one of the things that most people would have no problem admitting as capable of showing humanity, but it is one that it is by definition exceedingly difficult to address in via archaeological methods. Isaac continues, and he tells us about a third difference between human societies and great ape societies. He tells us that the acquisition of food between humans is a corporate responsibility, an activity that always involves exchange and sharing among adults and adults and young. He tells us, on the other hand, that food acquisition among the apes is a solitary affair. Apes eat whatever they find, wherever they find it. There is no sharing between adults. The only sharing is between mothers and babies. But after a certain point, that too stops. So the difference is that the one engages in immediate gratification. You eat wherever you find, whenever you find it, and the other generally engages in delayed gratification, brings back the food to some sort of a camp where it can be shared with others and so on. And so humans typically postpone consumption of some of the food that they obtain until they return to a home base where food is shared. Apes consume it on the spot. Why this difference is important is explained by Isaac, who notes that that food sharing promotes complex social and economic interdependence, that forms of interdependence that are essentially different from anything seen in primitive societies. The social interaction that takes place as a result at times of food sharing, he argues, would have generated selective pressures for communicative and intellectual skills. In other words, in those individuals most able to better communicate would eventually fare off with those individuals most able to better communicate, producing offspring that likely shared those characteristics. So it would have been a selective pressure for generating some sort of a ratchet effect in which those particular characteristics of the ability to communicate and exchange would actually be reproduced within societies at a disproportionate rate. This same point has been addressed by a number of other scholars, most recently by Robin Dunbar from Oxford, who argues, and I quote, "Language evolved in response to the selective pressure of maintaining social relationships in ever larger groups. And that would have taken place in part at times of deferred gratification and the sharing of food collected elsewhere and the sharing of food with the group." Another scholar, Michael Tomasello, a linguist in this case. So the other scholars that I mentioned are biological anthropologists. Tomasello is a linguist at Max Planck Institute in Leipzig. He published a book entitled The Origins of Communication, in which he argues, and I quote, "Language is about creating shared goals whose purpose is to facilitate cooperation." For Tomasello believes that one of the things that makes us human, that makes us different from the great apes, is that humans naturally have a cooperative, what he calls a cooperative instinct. This cooperative instinct that he argues co-evolved with language and is inseparable from it. Chimps and bonobos, he argues, have little of the sharing behavior that comes so naturally to humans, even to infants. Very small children, when given a set of toys, they're as likely to share the toys as they are to fight over the toys. The equivalent infants among chimps and bonobos would simply not share the toys at all. There is no, the cooperation that comes so easily to humans, presumably and in part associated with language, is simply not there in chimp societies. So if you were, in great ape societies, so if you were to ask Tomasello what makes us human, he would probably reply the cooperative instinct that humans have and that great apes seem largely to lack. Cooperation is very, very important indeed. Another one of the points that Mr. Isaac makes involves cooperation. He notes that although chimpanzees usually hunt, their prey is commonly much smaller than themselves, whereas human hunters are capable of complex cooperation so as to be able to capture animals much larger than themselves. What makes this cooperation possible, this complex cooperation possible, of course, is language. And in turn, language provides an adaptive selection for its bearers, for cooperators can provide more food for themselves and their families, which in turn selects for their survival, passing the cultural tradition of cooperation and communication and complex communication to the next generation. A clear example of the coevolution of genes and culture. So essentially, the point that all of these authors are making is that activities that involve a significant amount of social cooperation are extremely adaptive, get selected, get passed on to the next generation, and little by little, humans have become significantly different from some of their cousins in the ability to cooperate and create collective action. A little later in this course, we're going to, or towards the end of the course, we're going to talk about the creation of early states, of early cities. That requires a tremendous amount, a tremendous ability to organize labor and to engage in collective action. And most ape societies would simply be utterly incapable of doing such a thing, whereas human societies are pre-selected and are perfectly capable of doing that, engaging in collective action. And the key there is language and the use of language to persuade others to engage in that collective action. So language, complex language, is absolutely central to defining what is human and what is not. But complex language comes associated with cooperation, the ability to engage in collective action, and it comes associated with those activities that we see in humans that we don't see in ape societies, which select for cooperation, such as the sharing of food. Another point he makes is that simple hunting and gathering societies have a small but effective collection of tools for procuring their subsistence, whereas ape societies, on the other hand, while they may use tools, those tools have never been observed. They have never been observed to manufacture complex tools. I've already discussed that. So it's not tools, but it is the level of complexity of the tools. The last difference is one that I briefly addressed last time, and that's the issue of sexual dimorphism. Among the great apes, sexual dimorphism is generally in the 50 to 60 degree range. Males are 50, 60 percent bigger, more massive than females. I have, as I mentioned earlier, sexual dimorphism, insofar as we have data, among the Australopithecines seems to be fairly significant. Lucy was 3.8 average, and if Lucy be representative, 3 feet 8 inches tall, and if Lucy be representative of fully developed females, female Australopithecines, then fully developed male Australopithecines would have been significantly larger. The Australopithecines had a much greater degree of sexual dimorphism than Homo sapiens sapiens, for instance, where the degree of sexual dimorphism today is only 20%. Sexual dimorphism, as I said, is a characteristic that is found in many across biology in species where there is intense competition between males for access to females. Sexually dimorphic ape societies, which the sort of sexually dimorphic ape, the sort of sexual dimorphism that characterizes the great ape societies implies a harem-like social structure in which powerful males have access to multiple females and many less powerful males have no access whatsoever. I think it's very clear that we would all agree that that is not something we would call a human society. Human societies have some degree of pair bonding, however imperfect that pair bonding may be. Now, if this is indeed the case, then potentially one could use the decrease, one could look at the fossil record and look at the decrease in the degree of sexual dimorphism between the male and the female of the species in order to try to ascertain when pair bonding became characteristic of a particular fossil species that we're looking at. In fact, pair bonding, in fact, the degree of sexual dimorphism of Homo erectus, about whom we'll talk a little bit later on, is about 20%, about the same as ours. Can this be taken as a proxy data indicating that they had transitioned from a harem-like social structure, non-human, to a human-like pair-bonded social structure? It's a hypothesis, an interesting one. It would indicate that pair bonding goes back 1.8, 1.9 million years, give or take. The first indication that our ancestors are different from the great apes, it was believed, was the ability to create tools. We now know that that doesn't quite fit. On the basis of that, the earliest fossils that could be directly related to tool inventories were those of Homo habilis, so-called because it was Homo habilis is Latin for handy man, handy because they can use tools. Homo habilis associates with the so-called all-the-one chopper tool industries, and there are millions upon millions of all-the-one choppers. In order to make an all-the-one chopper, you need to take a particular type of river rock of a particular weight, and you need to hit it in 3 different places at a particular angle with a particular level of force in order to create a cutting edge. And we have evidence of millions of these. So very clearly, you also have the ability to teach others how to do that. So the creation of these stone tools, standardized stone tools, you've seen one all-the-one chopper, you've seen them all, implies a society in which one individual can explain to another individual by whatever means, gestural or sonic, what to do and how to do it. That is a society that has a culture. And very clearly, we can ascertain this in Homo habilis at about 2.6, 2.4 million years ago, give or take. There are some discoveries of tools, there are some discoveries of stones that some have argued may represent tools that are earlier than 2.4, 2.6 million years. and some have argued potentially could associate with Australopithecines. But if so, the two have not been found in direct association. And many have looked at the earlier tools and have argued that they're not artifacts, but they're rather ecofacts, namely tools fragmented by natural processes as opposed to consciously by somebody trying to create a tool. So I would not be surprised if there is a definitive finding that associates the origins of tool making earlier than 2.6 million years ago. But the ones that there is little debate are associated with Homo habilis at 2.6 million years ago, give or take. And all the one choppers, which I showed you before, there on the bottom, they are attested up to 1.92 million years ago, give or take. So we have a standardized tool type that was in use, that was made by the millions, and was in use by at least 500,000 years. So people were able to teach others how to make these tools. People were able to teach their children how to make these tools. So if you can teach somebody else how to make a particular tool, you can talk about nature, you can talk about the sun, or you can talk about something else. You can communicate many other things. The ability to teach a technology doesn't happen in isolation. It's part of a much more complex cognitive set of cognitive abilities. So it's very clear that these people did many human-like things, Homo habilis. And yet, when you actually look at the fossil evidence that we have for Homo habilis, the degree of sexual dimorphism in Homo habilis appears to be not all that different from that of Australopithecines. The point I am trying to make is that if indeed there is a set of characteristics that make us human, that set of characteristics that make us human did not arise as a package, fully formed one day, and get selected and reproduced later on. It took quite a bit of time for that particular set to get assembled into one coherent package. So more likely than not, the next point in time is Homo erectus, which appears in Africa at about 1.8 million years ago, give or take. At that point, something else I should note. If you have the ability to make a stone tool, if you have the ability to teach somebody how to make a stone tool, you have, in a sense, the same motor abilities that you require to make a tool are the same motor abilities that you would require to communicate gesturally. So the origins of language and the origins of tool making may actually be associated. Again, it's a theory, it's a hypothesis. It's difficult to test. By the time we get to about 1.9, 1.8 million years ago, we see the beginnings of another hominid, a potential hominid ancestor that looks a lot better as something that we would be comfortable calling a hominid ancestor. And I am talking about Homo erectus. Homo erectus it has a sexual dimorphism of about 20%, not all that different from you and I. It was so-called Homo erectus because it was first discovered in the island of Java, near the modern city, near what is today the modern city of Jakarta in Indonesia, in 1891. And when it first was discovered, remember 1891, there's not a single fossil that has yet been found in Africa. When it was first discovered, it was thought that it was the first bipedal human ancestor. We now know that that is not at all the case, but that's why it was called Homo erectus. There are some significant differences that are taking place across the line. When you actually look at the cranial capacity of Australopithecine, it's not all that different from that of a chimpanzee today. By the time you look at a cranial capacity of Homo erectus, you're looking at a cranial capacity that has grown by a factor of 2. Modern humans are weird. by weight. The size of your brain depends, of course, on it's correlated with the size of your body. Human brains are about 3 times bigger by body mass than the brains of the great apes. Human brains are exceedingly expensive organs. Your brain consumes about 20% of the energy that you ingest. In order to have a brain that large, you need to ingest a lot of energy. So, and this is a very important, and so the question is, when do you see a significant increase in cranial capacity? And the answer is that takes place with Homo erectus. So Homo erectus not only has a significant increase in cranial capacity, but now has to have a significant increase in the ability to maintain that very expensive organ, which is a larger brain. Homo erectus is very special in all sorts of other ways. Homo erectus is the first of the hominids that is able to leave Africa. As I said, the very first examples of Homo erectus were actually found in Indonesia. But examples of Homo erectus in Africa date to 1.9, 1.8 million years ago across a whole variety of locations in Eastern Africa. There are some that have been discovered in the state, in the country of Georgia, at a site called the Manisi, which is in the Caucasus, dated to 1.6 million years ago. The ones in Indonesia are dated to 1.2, 1.1 million years ago. So it is very clear that the earliest Homo erectus are appearing in Africa, but they do not stay in Africa for long. It is the first hominid that is complex enough, intelligent enough to negotiate the world outside of the subtropical jungles of Africa, outside of the subtropical jungles and savannas of Africa. So when I say that Homo erectus has been found in the Caucasus, you have to think in terms of a species that is capable to survive in temperate climates. And what would be necessary for survival in temperate climates? Yes? Fire, absolutely. The ability to create a microclimate. And you do that, of course, via a new technology, fire. So we're running out of time today, but I will talk a lot more about what is probably one of the earliest technological revolutions of the human race, and that is the ability to create, to control fire. Fire, of course, exists in nature, but the ability to recreate it at will, to control it, is very important. So without that ability, we could simply not conceive how Homo erectus ended up in places like China, Georgia, Java, and so on. So it is the first hominid successful enough to conquer the old world. And the question is going to be, why? What made it so successful? That's one question. The next question is going to be, what impelled Homo erectus to leave Africa in the first place? And that's where we'll start next time.